All right, so let's talk a little bit about casting and what it actually means. So we can think about an actor being cast in a specific role in a movie. So over here in this picture we have Kenny Baker, who's the actor that played R2-D2 in the Star Wars series. So while he was in that movie, he was playing a role as R2-D2, but outside of that role, he was Kenny Baker. And we have a very similar concept that we can apply in programming. So say we had the following C++ code. So we have a declaration of a variable of type double called x, and we're assigning the value 5.25. And then we have below that the declaration of a variable of type int, and it has the name y. And if we do this sort of assignment operation where we assign the value of x to y in C++, what are we doing? We're actually taking a value that's of type double, which may be represented by 8 bytes, and storing it into a variable that only has space allocated for 4 bytes. And also, what do we know about ints? They're not able to represent a fractional part. So what happens in C++, it actually allows this operation to occur. Depending on what kind of compiler you have, C++ compiler you have, you may get a warning or you may not. Regardless if you get the warning or not, an implied cast is occurring here. So what that means is the compiler is taking care of transforming or converting the double value into an int value for you. Now you can also do what's called an explicit cast. And what this means is you're actually telling the compiler, I want to convert this particular value for this specific expression to something else. So we could do a very similar thing here where we've actually explicitly stated that we would like to have the value x, at least for this operation here, this assignment operation, to be an int value. Now the same thing happened behind the scenes here, but here we're being very explicit about it. And so if you have a compiler that may have complained here and provided some sort of warning saying that you may have lost some precision, in this particular case you're letting the compiler know that you're okay with that loss of precision, that you're not concerned about the fractional part. So let's look at another example real quick here, where we have maybe y, and we're dividing it by 10. So if we look at what we have so far here, the value of y should be 5, right? So originally we had x assigned 5.25, then we assigned that value to y. Y was of type int, so we lost the fractional part in both of these cases here. And so it should just be an integer representation of 5 here. So we have 5 divided by 10. So the result of that should be 1/2 or 0.5. But x over here is of type double, this is of type int, and this is what we call an int literal. So whenever we perform this operation here, since we have an int divided by an int, we actually, what happens here is we end up with what's called integer division, and we actually lose the fractional part. So this is not good enough. So even though we're assigning it to x, which is of type double, we're losing the fractional part before we even get to the assignment operation. So this is not a good thing. We actually need to do an explicit cast in this case to avoid losing that precision. So we can actually explicitly cast either the y or the 10 to be of type double. And I'm going to show how to just do an explicit cast for the y value. So here we can actually do this explicit cast, and what we've done is just put the name or the type that we want to have in front of the variable or the value. So you could do the same thing over here in front of the 10. We're changing this to be of type double. So now we have a double here and we have an int here, so it ends up doing what we call floating point division. Okay, so it actually is promoting this guy to be of type double, and it performs floating point division. So in that case, we actually do not lose any precision there. Now, if we were to come down below here and actually talk about the variable y would still be an int value. It was only cast as a double for this particular operation here, this assignment operation. So anytime we use y after that, it would still be representative of an int. who was only playing the role of the double or cast as a double in this specific statement. And that's basically it.